Okay, things that I really wanted you to hang on to from that square roots and surface area, so we're just focusing on the square root part today, was being able to promptly list the first 10 perfect squares. So 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Okay, this is a skill that's going to come in really handy next year in Math 10 too. Okay, so these were our perfect squares. Perfect squares, again, let's talk about what that means. It means that they have two exact factors. So 1 times 1, 2 times 2, 3 times 3, etc. Okay, so what are the square roots? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, and of course some of you know 121, 144. We can keep going there too, but these are basically the ones that we were going to put sort of to memory. Okay, and so what I really considered important in this unit was being able to benchmark, okay? And so I would give you something like this, the square root of 24. And we talked about how that's not a perfect square and it's also an irrational number. And this is what's key, is knowing the difference between a rational and an irrational number. So a rational number was a number that we could write in fraction form, okay? Now, if you plug this into your calculator, you are going to find out that it is a non-terminating, non-repeating decimal. And because that decimal doesn't end, there's no way we can write it as a fraction because we have no place that we can write a denominator. Okay, so what we did instead was we benchmarked, or in grade school you might have talked about it as estimating. Okay, so what I wanted you to know was that 24 comes between the two perfect squares of 16 and 25, and it's much closer to 25. So we know the answer is somewhere between 4 and 5, but closer to 5. So what would be a really good guesstimate or benchmark would be like 4.9-ish, right? It's not exact. Okay, and just understanding that this is still a irrational number because we wouldn't be able to write it as a fraction. Okay, so let's try one more together. Let's try 38. Okay, so the first question I'm going to ask you in Math 10 is this rational or irrational? And you need to be able to tell me that that's going to be an irrational number because we know that 38 is not a perfect square. So if we plug that into our calculator, what's the square root of 38? We're going to get a decimal number. For right now, though, I want you to be able to tell me that 38 is somewhere between the perfect squares of 36 and 49, but a little bit closer to 36. So somewhere between 6 and 7, but closer to 6. So what would be a good guess? Maybe 6.2, okay? And remember we talked, I'd accept anything that's under 6.5. Once you say that it's 6.5 or greater, what you're telling me is it's probably closer to 49, which it's not. Okay, the other thing we did was we talked about finding the square roots of fractions. So if I asked you to find me the square root of 16/25, okay, and what we did was we took a look at the numerator and then we took a look at the denominator. So the first question I'm going to ask you is this rational? And the way that we answered that was, is this numerator a perfect square? Yes. Is the denominator a perfect square? Yes. Therefore, we know it's going to be rational. So if we figured this out, the square root of 16 is 4 and the square root of 25 is 5. And there you see it, plain as day. It's written as a rational. It's written as a fraction. So if we tried another one, 17/36. Okay, is 17 a perfect square? No, it's not. Okay, 36 is a perfect square, but it can't just be one. Okay, it has to be both. So we could still benchmark this though. Okay, we could say that 17 is close to the perfect square of 16. So we could say that it's close to 4, and 36 happens to be a perfect square, which is 6, and then you'd reduce this to 2/3. Okay, so it's not a rational number, but we can still benchmark that whole idea. Let's try another one where we benchmark. Okay, so let's say 8/63. Okay, is 8 a perfect square? No. Is 63 a perfect square? No. So if I asked you, is it rational or irrational, you could tell me that it's irrational. But what's the closest perfect square to 8? 9. So I could rewrite it like this. And what's the closest perfect square to 63? 64. And then I could benchmark it by saying the square root of 9 is 3 and the square root of 64 is 8. And we'd be close. We'd be very close. Okay, so I'm just going to post now a real short assignment, and I just want you to work through this and think about your perfect squares and how to find the square root and benchmark squares. Okay, square roots.